So, yes, so procedurally generated planets. Yeah, that's way smoother over here than it is up there. Trust me, that is so smooth. So that's what we're talking about. There's, this is, as I say here, I said it, or a chance. That should probably say, or an excuse to talk about .NET Core, WebGL, and Three.js, which just happens to be stuff that I enjoy and am interested in. But there actually is an origin to all this. I just want to call out a couple of things on that cool planet that's spinning around. There are multiple layers applied to that sphere. There is a layer that represents the landmass that is completely randomly generated. There is a bump map layer that is adding all the little wrinkles to the contours and the coastline sort of bit. And there is a cloud layer on top of that. And we're doing some variable light source and some shadows, and not maybe immediately obvious in that, but there's also a tiny little bit of a glow effect. It's not very strong there. And there's a reason for that too. So the reason that I did this, and I apologize, but I printed my notes, so I am going to be flipping pages. So 10 years ago, I wrote a really dumb little .NET app because I had a game idea and that went nowhere because I have no time to work on game ideas. But in this game idea, I needed lots and lots and lots of like cool looking spinning planets. So that was the origin of it. There were several things that I wanted to play around with in doing that. As I said, I wanted to generate a whole bunch of them. The more I played with it, I spent a lot of time writing this little generator. I spent 0 time writing anything remotely relating to a game. But I sure did had lots and lots of options because that was the fun part, was just doing the generation of this stuff. Yeah, so here's a funny thing. Originally this was for Windows, and Windows Phone is what I was aiming for. This was supposed to be a mobile game that I was trying to think through. Not much point in that. So part of what I'm presenting and talking about today is this thing that has been sitting there for 10 years. I've started to play in .NET Core, which I think is really interesting. It's kind of the new cross-platform version of it. I wanted to see, like, pick an old project that I actually finished and did something, and mainly how hard would the process be if I actually wanted to spin that up in .NET Core and run it under various other platforms. So a lot of that was just a matter of that. I wanted to see what the process was like, and that was the focus of my activity. So we're going to actually play with it in just a minute, but this is basically the old 10 years ago .NET WinForms app, because writing command line stuff is great, which is what I converted this to when I did .NET Core. So it has a million command line options to represent all this stuff that I did in the old version. But it was a lot more fun when I was playing with it to like really see visually what I was working with. So I did things like this main screen lets you choose from different types of planets. I had all the like existing solar bodies in our solar system represented by nice maps that I could layer onto the spheres. I could control how many frames I wanted to generate and how smooth I wanted to make this rotating planet, change the size and the resolution of the images it was going to create for that. The whole point of this, when it was all done, was to give me individual PNG files as frames or a nice little animated GIF, which is what that was on our first little slide. And then the more I played with it, the more I enjoyed futzing with the options for like where the light source is going to be and how I'm going to do the shadow and what's the strength of the shadow and should you be able to alter that color or should it like figure that out from like taking an average color from the planet itself. Same way with the glow effects and things of that nature. And then after that, I ran across this wonderful little ancient piece, 20-year-old piece of C code that we will look at eventually. That was somebody else's little personal project that was all about generating these bitmaps for these things, given a random seed and generating all this stuff just completely randomly. So that's kind of what this was all about. It was done in, I have no idea, ooh, I don't want to go there yet. It was done in the version of Visual Studio that existed at the time. I'm just going to switch over to it. Oh, no, that's a confusing view. I don't know why I've got two docs, but we're not going to worry about that. So this is the old version of the app that I started with. The other thing that I wanted to do is, at the time, I had never written a ray tracer. So it's not the most complex thing in the world to write. So I purposely chose that is the way that I was going to attempt to take a sphere, take all those parameters, take these bitmaps and the lighting sources, and do that was to write a little ray tracing algorithm. So that is absolutely what it does. So if I'm just going to tell it to render me a single frame, and there's my Earth, and I let it go do a bunch of different ones. Well, it's not going to do a bunch of different ones. I have it set on only 30. So the thing about ray tracers is ray tracers are not very fast. At least not ray tracers done in software that don't have some kind of acceleration. So it is a really fun learning exercise to learn what that process is like. It's just not very speedy. So this worked great for what I wanted. But as you can see, it's not the fastest thing in the world. In fact, come on, I wanted you to finish, not wait on you to render frames. And we're almost there.
I have a question.
Let's hear it.
Is whatever processes that are going on right now, is that something you could multi-thread?
Absolutely. The truth is, 10 years ago as a WinForms app, actually that would have been difficult because it's using GDI for this, which really doesn't like to be multi-threaded. So there are things I could do to try to work around that.
Right.
Or I could have tossed GDI and used some other library to do that was more multi-threading safe. But yeah, absolutely. At the time, it was just about, can I make this thing do what I want it to do? Which it does. And once again, I'm sorry, it's not so smooth on screen link here, but you get the idea. So yeah, the idea was that I could go in here and I could change all these rendering properties. I could change the way the glow effect worked, or whether I even wanted that. I can do all sorts of, we're not going to spend too much time in here because I like to play with this thing. I could spend lots of time in here. I started adding ridiculous stuff like lens flare effects and a lot of other things I added. I'm not even sure that this even makes sense, although it's still in the new .NET Core version. But you can have the clouds move at a different rotation speed than the planet moves, which is kind of cool because when your end result, you can really tell. It doesn't look 100% realistic, but it does look cool. So that's what all this stuff was about. And then this generator parameters is where I don't want one of the existing solar bodies. I want to make up one of my own. And I will cover this in a little bit, but I've got all sorts of things I can play with here and generate cloud layers and formations of earth and water, and I can change the density of all that sort of stuff and all that sort of stuff. If I generate that, stop that, make a generated one. Oh, well, there you go. There's the first frame of what that weird-looking planet is going to look like. So we will get that out of the way. I will not spend any more time playing with that app.
You're looking at a preview of your recording.
Oh, is that what I'm doing?
You can't click on it.
Okay, let's see. So there's my recording. I mean, my actual slides. Much better. Okay, so Those of you that know something about .NET, I'm going to totally bore you with a bunch of slides. And those of you that don't know anything about it, I'm going to totally confuse you. So .NET has been around a long time. And before I can explain why I would even use .NET Core for this, I have to give a little background about where it's come from and what .NET looks like right now. The .NET framework constantly has had different names as of the last few years. We've now got what we call the .NET framework. We've got .NET Core, and as you see on this diagram, we've got something called Xamarin, which I will cover in a minute. The .NET framework, as I mentioned here, has recently been relabeled by Microsoft as .NET Classic, which should be like a sure sign of the death knell of a product. Whenever they decide to call it Classic, you are in trouble if that is what you're still doing. Xamarin, however, has its origins in the Mono project. We'll cover that in a minute as to what that is and where that came from. .NET Core is a completely separate effort from Mono with a lot of crossover. And I call out Miguel de Casa because it is definitely him driving. So, the one thing I didn't talk about, if anybody went and looked for what are the flavors, what are the additions, what are the targets that I use for .NET, is this one called .NET Standard, which is extremely confusing. And I'm actually going to call out something here at the very end of that, which is the first version of some of these products. They introduced something called PCLs, or a portable class library. And the intention was like a DLL on Windows, a dynamic link library, where I'm going to take some code, I'm going to compile that code, I'm going to make a DLL that can be linked in to some other application or some other development environment, and I'm going to use whatever methods and APIs exposed in that. PCL was meant as a, oh, we're going to do this cross-platform stuff, so we need a way to do the same sort of thing. So it was an attempt at a cross-platform version of that same idea. It has since been somewhat supplanted. In fact, I think officially they say don't do PCLs, to like stay away from it. And what they want is, if that is what your intention is, they want you to target what they call .NET Standard, which is weird because like all the other things, unlike all the other things, .NET Standard is an interface. It's not a framework. So it is a core set of API definitions that is part of a spec. I don't know if I'm not even sure what version we're up to with .NET Standard. I bet Jay knows. I think 2.0 maybe is what the current .NET Standard spec is. That spec defines all the different interfaces that are part of the framework, but .NET Standard is not like a library or a framework. It does nothing. It just defines all those. So if you target that, the idea is that things in the regular .NET framework, Classic, or .NET Core can choose to take those interfaces in .NET Standard and do their own implementations of it, which there's no way I can't read that up here, so I know y'all can't read that, which is too bad, because that's a really good diagram, because it does really spell it out. In the middle, basically, in this example, there is a part of the .NET Standard spec, a namespace called iNet Standard 1.5, or I think it's actually 1.0 in his diagram, that's a part of that spec. And so that means that current one, the regular .NET framework, has chosen to implement that spec. And .NET Core, the current version, has also chosen to implement that spec. So the idea is that, oh, if I write something to .NET Standard, and that's my class that I'm creating, as long as I stick to things that are in that spec, they're going to be supported and compilable regardless of which version of the .NET framework I choose to go, which is why sort of kind of makes sense as to why it's a replacement for that whole PCL idea. So it's meant to be just a spec, not a framework, but that is like where you write the code that you expect to be reusable and cross-platform against different versions of the framework. I did say it was going to be confusing. So what about Xamarin? Okay, Xamarin is kind of weird. So the Mono project, as noted here, that started in 2001, was an open source compiler for C# and the CLR. That's the Common Language Runtime. Think the JVM if you're a Java person. Originally, the whole intention was that it targeted Linux. It was started by a little company called Ximian by two guys, Miguel de Icaza and Nat Friedman, with this weird okay, we won't sue you for doing that relationship that they had with Microsoft. The .NET framework by no means at that point was under any kind of open license whatsoever. So it really was a we don't sue you kind of deal. But there were people within Microsoft who kind of supported what they were doing and supported the idea of what they were doing. So there was real effort, but 2001 was a long time ago. I can't even remember if that was still Ballmer running the company or if that was before Bill Gates left. I'm not sure exactly when that occurred, but there were plenty of people in the company where there was some serious argument about whether an open source version of .NET was ever going to be a good thing or something they would ever officially support. Mono went through a bunch of changes. They got bought by Novell soon after they got started. Then Novell got bought by Attachmate, I think, which I can't even remember what they made. A spreadsheet? I don't know what it was. When they did that, there were huge layoffs at Novell, which at that point was a gigantic company. Those layoffs affected most of the people that worked at Novell that came on board as part of the Mono project. So the original founders and some of the rest of the engineers left, started a new company called Xamarin. Xamarin's focus was all about how can we use C# for writing mobile apps, because that had become a thing. So, and in particular, how can we like target iOS and Android platforms and still write C# code? That went along actually maybe a little too well as the fact, as you see there in the date as to when the big changes happened. Things changed at Microsoft, and they got new leadership, and they got incredibly different directions when it came to how serious they wanted to take open source. So that went along for quite a while. I think at its heyday, I think they had almost 2 million developers had licenses for Xamarin. So, I mean, they had an audience. So Microsoft bought them. But they actually did a little bit different than their normal, embrace, extend, take it over, and replace it with something different. When they bought Xamarin, they actually did that because they didn't have a great solution for doing the same thing that it provided. So once they purchased it, they started bundling all those tools into Visual Studio. So nowadays, the full version of Visual Studio, actually I think all the editions of it all come with all the Xamarin tools in there. Meaning, they don't want you to, for one thing, they don't want you writing, apps for iOS on a Mac. You should definitely do that on Windows. And probably most Android people are using Windows anyway, but hey, why not go ahead and do that under Visual Studio? Mono app, I do want to call out, Mono apps were typically built with an open source IDE that continued all the way into the Xamarin era. It just got rebranded a time or two. So originally it was called Mono Develop. Eventually, when Xamarin came about, it got turned into Xamarin Studio. And the only other thing that I want to call out is about the two guys, which are both, actually, you know what? I don't know anything about Nat Friedman. He may be a perfectly nice guy. Although Daryl will find this interesting because my boss at the company I work for now, Miguel and Nat Friedman and Xamarin were all based out of Boston, which is where the company I'm working for now is also based, and where my boss has worked for this company for like 20 years. And he only knows Nat Friedman because he, in the middle of Boston Common, came across a book bag, a laptop bag that somebody had left, and he opened it up, and it had a phone, and it had a laptop, and he had no other identifiable information, so he had to take it back to work, and he had to boot it up, and like, whose is all this sort of stuff? And he figured out it belonged to this guy, Nat Friedman, which he then tracked down and figured out who he was and contacted him, and according to our boss, he was a jerk. In fact, he was apparently extremely put upon to have to like meet our boss somewhere and get his laptop and his phone back. So whatever. Miguel is a impressively awesome dude. So I think there's a lot more knowledge about him. He has been like super involved in the open source community for a long time. Although I will call out, to me, what is the funniest thing about Miguel, which is that in 2009, Richard Stallman called him, oh my goodness, where did we go on that about that? Oh, I'm so sorry that I didn't put the quote. Basically, he said that Miguel was a traitor to the open source movement. And you know, if he'd had an inheritance, he would have been written out of it. Was really all about the Mono project and what had happened. The reality is, at the time, Mono still had some adoption. And what had set off people like Richard Stallman is it originally started with this weird license with Microsoft of the "we won't sue." Basically, there were patents covered that belonged to them that were covered in the technologies in Mono. Everybody knew that. Microsoft did this agreement to like promise the community we won't do anything about it. However, Miguel and the Mono team kept going farther. They kept pushing it, and they kept integrating other technologies that fell outside of that "we won't sue you" patent deal. Hence the "you are a traitor to the open source community" comment. Understandably, because it like really stalled a lot of things with Mono. There was a lot of thought in the open source community that this is like this is the hugest patent infringement suit ever, just like waiting to happen if anybody really builds stuff on this product. It was a mess. So, .NET Core, what is it, and what is it, how is it different, and what is it all about? The license here is a big deal. So the first thing that they did is the .NET Core comes out or is organized or run by a group called the .NET Foundation. It's an independent organization. Miguel is one of the directors. It is, well, you're seeing what the official blurb is as to what the point of the foundation is. The big thing, other than the fact that there's a whole lot of projects that fall under the purview of the .NET Foundation, is that they threw out all that "do not sue" stuff and decided when they were going to redo .NET Core as essentially, it's easy to think of it as what's the difference between .NET Core and Mono, which was a, you know, we're going to port an open source version of a clone essentially of the .NET framework, is this one they decided to start over, be serious about it, release it open source with this foundation, and it all uses the MIT license. So it did two things. It allowed people to take it a little bit more seriously when it came to whether the license was really open enough to involve that product. And it also, strangely enough, allowed them to go back and redo the relationship with the Mono project, and they applied the same license to that. So it kind of saved what was the Mono project at one point. It's arguable as to what you would really use that for now, but it is still out there and it's still going. .NET Core is available for Windows, Mac OS, and Linux altogether. You see some dates there about when the versions have come out. 1.0, 2.0, 2.1 is the current, and 3.0 is currently in preview. But you can see on the dates that it's pretty aggressive. I mean, every year we're getting an entirely new full version. A lot of that is because it originally started as a really small subset of the overall, what we all considered to be .NET. .NET is a framework with 1 million namespaces that cover everything you could possibly imagine and a lot of functionality, and .NET Core 1.0 was a very small little subset of that. And further versions increased it, 2.0 increased it. It keeps going on all that. .NET Core has got full language support for C# and F# on purpose. That was there since the first version. That has continued. That will continue to continue. It has this weird partial support for Visual Basic.NET that has been totally secondary, and it's one of those things that you can almost kind of do something with it. Basically, you can write VB.NET .NET Core code and build it, but there's no runtime available that supports it. So you can build but not run. It's essentially utterly useless. However, this preview version of .NET Core 3.0 is going to include a whole bunch of other stuff, including full support for VB.NET. Just say no, don't do that. So there are currently 4 cross-platform scenarios that this version supports, meaning the not preview release. ASP.NET web applications, command line applications, libraries, including still PCL, but we talked about that and why .NET Standard is what they want you to do now. Universal Windows Platform apps, which I guess some people are writing. Core 3.0 is basically adding what was missing. So new scenarios for desktop applications, AI and machine learning applications, and IoT stuff. It uses a CLI, like all the cool things do now. And it's pretty sophisticated. Let's see if I can find my browser. Okay. Only because I'm never going to remember what's in there right now. It's very much like doing things like using the Angular CLI to create projects based on templates. What I wanted was, so you can see these are the templates that are baked in with the current version, not even with the preview. So it's crazy amounts of templates. You want to do ASP.NET web applications with MVC, you want to use Razor pages, you want an Angular app, you want React with Redux. And it's kind of interesting because this whole infrastructure is also totally open. So there's a ton of other templates that are easily added using the package manager onto this. So you want Knockout or View, all those things are in there and ready to go. So lots and lots of stuff. Okay, so we covered the .NET framework stuff. I don't know whether I just made that more confusing or less, but I'm going to hope for less. This is going to seem like a silly exercise. However, VS Code is so good that I constantly run across people now who think that VS Code is Visual Studio. and it is not. So it's confusing that they use that name, as well as the fact that, like, currently there really are 3 completely separate products. Visual Studio in those 3 editions, Community, Professional, and Enterprise, VS Code, and Visual Studio for Mac are 3 distinct and completely different products. Visual Studio, which in very typical Microsoft fashion is almost always called by a year number. So we're like the current preview, we're waiting on the release of Visual Studio 2019. The current version is 2017, because you can never tell where they're going to skip a year. And it's one of those things that, just like they've always done Office and all their applications, they long ago decided we're going to call them years, but they use a completely different versioning system actually inside the application. You look on your drive and you're like, that's not 2017, that's version 15 dot whatever. So not confusing at all. This is the full Windows-based IDE for all development scenarios, basically, that .NET can handle. And by that, I do mean if you're using the full version of Visual Studio, you are using so on Windows. But that means all those versions of the framework we talked about. You can target any version of Classic, you can target .NET Core, you can do your work and target Xamarin, whatever you want. As I mentioned, it is now totally integrated with Xamarin tooling, which is pretty cool. They did that across all the versions. The Community is the free version. Pro and Enterprise cost money. In some cases, a lot of money. It is an insanely powerful IDE and insanely gigantic and huge and fat. So the minimum install for Visual Studio 2017 is 600 megabytes. And if you choose all the workloads, that's a shame you can't read any of that. If you choose all the workloads, like, select all, 82.58 gigabytes. That's the install size for Visual Studio 2017. I would bet the new version is probably not going to go down any. So it's nuts. The costlier SKUs, the nice thing is the fact that there is a Community edition has not always been the case. I'm not sure how many years ago that first got introduced or which version that was, but it used to be Visual Studio always cost big money. The nice thing is now is the Community version, there's like almost nothing you would want in the paid versions. The Community versions are fantastic. Usually the only thing you're missing is the heavy duty like testing infrastructure and source control integrations that are all into things, into testing frameworks and source control systems that you don't want to use anyway. So there's absolutely nothing to lose at all in the Community versions. Visual Studio for Mac is a complete red-headed stepchild. That is because it says Visual Studio for Mac. That's not really what this is. This is, remember we said that the Mono project, they wrote their own IDE called Mono Develop. Went through all those permutations, got a new company, we called it Xamarin. They've done all sorts of additions and changes and added features, and they rebranded it as Xamarin Studio. Yeah, that's what this is. Visual Studio for Mac is the latest rebranding of that same product. So they've done some things like take the editor and the IntelliSense engine that was in the full Visual Studio and moved it over into this product. But other than that, there's no real similarity. The only reason that I have figured that this product exists whatsoever is it's for developers who are working on a Mac and they want to target Xamarin. Yeah, for whatever reason, they don't want to do iOS or Android development in either Kotlin or Java or Xcode. If they've got a reason why they want to do that in C#, F#, and .NET, this is the tool for them. Only so they don't have to have a Windows box to do all that same stuff in the full version of Visual Studio.
Or a Windows license.
Or a Windows license. Oh,
I assume.
and I did call out one other thing. And actually, you could write Mac Cocoa apps with this. So that's one additional thing that you can do. The ugly thing is if you do that, you have to use the Xcode interface builder. so it's kind of a hodgepodge of interface builder, but it's like a C# backend to that. Okay, VS Code. Everybody I'm sure in here has played with VS Code. It's an open source editor with support for debugging. I guess whether you call it a full IDE is up to how you define that. Like everything that comes out of the .NET Foundation, it is all done via the MIT license. Some things that it's got that are pretty cool is it's got really good embedded Git control. It has a gigantic active plugin infrastructure, which is a huge deal. I kind of feel like all the activity and excitement before VS Code was really all about Atom and everything they were doing in that same sort of space. In a certain sense, it really feels like VS Code has kind of supplanted that. There seems like there's more activity in the plugin infrastructure. Released in its first form in 2015. It's available on everything. And yes, just like Atom, it's an Electron app. Although, anybody can attest to this, I would argue it's probably the best Electron app. It's the least I can tell it's an Electron app of any Electron apps that I use. Sorry. Does everybody know what an Electron app is? Electron is, sorry, I just realized maybe I should ask that question. So Electron is a framework for, I want to build desktop applications, but I want to build them all in the Chrome engine. So really what I want to build is web applications using web application technologies that all run in Chrome, but I want to embed that as a desktop application and also give me access to all sorts of local PC hardware, the kind of things that you would expect a desktop application can do. Slack is an Electron app. So is Atom, so is, help me William, what are other biggies? I'm sorry? Discord. Yeah. Well, I would argue against that, but any application that also lives in what seems like an absolutely identical version on the web, absolutely. Why would you not? If you're going to put all the effort into building that, it does make sense. Why would you not? Well, I'll use Electron, and that's how we're going to build our desktop app. So yeah, in Slack, there's no difference really between it and using the website for good reason, because it's essentially the same thing. Yes.
Electron apps. If I have two Electron apps open at once, say Spotify and Slack, do they use the same Chrome?
That's a good question, because here's the thing. So my question would be, Jonathan, if you use Chrome, how would I even tell? Because I have like a million Chrome processes running. I don't know the answer to that. But it would seem like the way Chrome handles that itself, yeah, I don't know. I would probably guess they both have their own instance of the engine. I don't know. That they each have their own, yeah. That's what I would assume. Yeah. Yeah, well, yeah, right. So it all depends, how much you hate that depends on what that Electron app does for you. If it does really small thing, then it feels like a terribly heavyweight application for this small thing that maybe I should just use the website version of that. But yeah, it's memory utilization and all that sort of stuff. It's not very light. Yeah. Doesn't require an 82 gigabyte local install though, so it's got some advantages. And VS Code is fast.
Does that depend on how many extensions you have installed?
I'm sure it does. Right. I don't know. I haven't tested. How many extensions do you have installed? Okay. We're going to shift gears a little bit. I promise I'm going to quit talking about .NET. Not entirely. We'll come back to it. So WebGL, because this talk is supposed to be about three things: .NET Core, WebGL, and Three.js, right? Okay, so you saw the little generate some planet stuff. The reason why WebGL and Three.js are in here whatsoever is that, remember the whole, like, I decided purposely, yeah, I want to write a ray tracer. I've never done that. And I got a really nice tool. It does what I want. Through all this exercise, I ended up with now a nice tool that I can run as a command line under Linux or on the Mac that does all the same stuff. That's all cool with the same code base. But it still does so in a pretty slow way. It's not multi-threaded. It's using completely, not taking advantage of the GPU in my machine or anything of that nature that you would expect could super, super quickly take that bitmap and wrap it around a sphere and rotate it around for me. Although the whole point of this little application was that, yeah, but I don't want to, that might be something I do in the game. But what I want to do is I need 2D bitmaps that only look like 3D spheres that are nice and smooth and rolling around. So it was applicable, but it made me start poking around a little with WebGL, because if you were using OpenGL or Direct 3D or anything else that would do this, yeah, you would have taken a very different approach. You would have set up a 3D scene. You would have created an object that was a sphere. All this, taking the bitmaps and using Phong to apply that to the sphere, all of that sort of stuff would be used. It's a whole lot more complicated, the kind of what that code looks like. But then you'd have something that was super, super fast. So I started playing around a little bit with WebGL. So it is what it is. It's a JavaScript API for rendering 2D and 3D graphics, just like OpenGL, because that is what it's built upon. It's interesting because it is GPU accelerated. WebGL elements can be mixed in with other HTML elements, and that's because it runs on the HTML canvas. Several things about it that are interesting. It contains a mix. It's actually quite complete in that it's not just a JavaScript library that's a front end to OpenGL. It actually is an implementation so that you can actually write stuff in OpenGL's shader language. So it's really sophisticated what you can do. It really is just I want to use all the stuff I can do in OpenGL, but I want to do it in a browser. There are two specs, 1.0 and 2.0. The thing to call out about that is that pretty much 1.0 runs everywhere. Any phone, I think 1.0 runs on BlackBerries. It really runs on just about everything. Well, we'll look in a minute, not nearly everything. 2.0 is very, very not in that condition at the moment. Part of the reason for this is where some of this came from, and the fact that this all originated out of Mozilla, out of experiments they were doing, is where WebGL came from to begin with. So as one might expect, current versions of Firefox always support whatever the current WebGL spec is. A lot of things, other things tend to lag behind a little bit. How am I doing on time, William? Do I need to hurry it up?
More than 25 minutes.
I'm just going to pull this up real quick, but there's all sorts of really fun examples out there that do stuff using WebGL. Yeah, a lot of them are silly. There's probably not any purpose in it, but there's all sorts of really fun stuff with full source that you can play around with. However, so this great big chart, which, by the way, I will skip going to it and showing it to you. Trust me, the link on here, this chart is interactive. Yeah, you obviously can't see it in this slide, but the idea is you can hover over any of the red and green boxes for the versions in the browser, and it goes way beyond. It truly covers every browser you've ever heard of and plenty you've never heard of, but it will tell you specifically what version of the spec it can do, and for the red boxes, it'll tell you, here's what doesn't work. So it's basically, it's like, they have a suite of tests. It's just like the whole HTML5 thing all over again. It's a suite of tests, and if it passes all these tests, it gets a green box. And if it doesn't, it fails certain things, it gets a red box. Although in certain cases, you may find that like even ancient versions of Internet Explorer might actually support it to the point of, oh, well, it does these things, and that's the things that I'm doing. So, might actually work in that anyway. Suffice it to say that the support is pretty darn broad. So this is a WebGL code example. Y'all can't read that, can you? Yeah. Sorry about that. Well, I'll just talk about it. So really what I want to point out is that before we move beyond WebGL, this is just like a quick snapshot I took of what this thing does, which is a cube, and each side of the cube has a different color, and it rotates around. That is 379 lines of JavaScript WebGL code to do that, which seems like a whole lot, and I would argue that it is. So when I was playing with it, I wasn't doing WebGL directly, because there is a really, really awesome, there's more than one, but there is this particular one that's probably been around a little longer than a lot of it. It's still very actively worked on and has a lot of contributors, called Three.js. It's got a lot of things going for it. It's a framework that's one file. I love that. It is just a wrapper around pretty much anything you can do in WebGL. And I'm not going to go through all these features, but it has tons and tons of features that they've already kind of wrapped up for you, especially like tons of like math and geometry stuff, which is awesome. So, because, a sphere is pretty simple geometry made up of a mesh of triangles, since these are all 3D objects. And who wants to like create all those meshes by hand, know how to make a sphere? I want to say I would like a sphere, and I would like it right here. So Three.js is great for all that sort of stuff. It also is completely cross-browser. It runs in any browser that supports the WebGL 1.0 spec, which, as you saw on that other slide, is like nearly everything. Like a lot of good things, it's also using the MIT license. It is, as I mentioned, still supported and active. It's kind of interesting because the guy who wrote this came out of like the demo scene in the early 2000s. So this like original code base was a 3D library that they had used with all this functionality for writing all these flashy demos. And then once WebGL came along, they had very smartly modularized all the rendering part of their graphics library. So they basically just like took their project and they rewrote the renderer to use WebGL.
Demos for what?
Come on, William, help me with like some of the names of the more famous ones.
I mean, categorically, like games, software.
No. All right. So they all came out of the Netherlands. I don't know what that's all about. So there was this whole thing, right? So it was, how small a piece of code, an executable, can we put up on eventually on the internet? But it started out on dial-in bulletin board systems that you run on your PC, that a lot of, sometimes there was stuff like that would get written in an assembly language and it was super duper optimized, and it would run a demo. It would have crazy 3D effects and 3D shapes and spaceships flying by and like pounding synth music, and it would do all that with whatever your crappy PC was. Okay, that was the whole point for these demos, was here's something, we're going to pass it around. And in Europe, in particular, in fact, there was like giant yearly conferences that got huge about this, that groups would form of developers that would form a group and have what essentially was like a rapper name for their group, and they would produce maybe their cool demo for the upcoming demo conference that was, once a year in some European country, and there would be a competition for who had the most amazing demos. And of course, they spread everywhere. So at a certain era of you had a PC at home, yeah, your like PC was littered with these things because you're like friends that would come over, your family members that like don't really understand a computer is for spreadsheets, and you would like pull one of these things out and run it, and they would be blown away. That's crazy. It's meaningless, and it's like pounding synth music. And it might be a virus. So this project came out of one of those demo groups. Yeah, one of those demo groups. I mean, I'm telling you, just go run it together, demo scene, just Google that, and you can see, actually there's on YouTube, you can find, you don't even have to go run the stuff. Probably doesn't run on modern PCs anymore anyway, but you can go watch tons of like YouTube videos of the most famous ones, and then go look at the year they made that, and it will blow you away. Yeah, really cool stuff. So, the point of this example is we're looking at nearly the entire code. There's actually a little bit in one little extra JS file that I didn't include in here, but this is nearly the entire bit of JavaScript code in using Three.js to do the same thing that we saw in the WebGL stuff that was 379 lines long. So it's just crazy easy to use. That's really what it comes down to. Finally, planets. Okay, I'll try to speed it up a little bit. So here what I'm spelling out a little bit is, so this is what the process actually is for doing this. I need a sphere. Doesn't matter whether I'm going to use a ray tracing technique or if I'm going to use a 3D library or whatever. I'm going to need a sphere. I'm going to need multiple bitmaps depending on how fancy I want to get with this particular planet, whether it's the Earth or Mars or something random you've generated, because one of those bitmaps is going to be basically the main texture that represents the surface. Probably going to want some kind of atmospheric cloud layer, maybe or maybe not. We need to be able to simulate a light source and preferably do this in such a way to where it's rendered and I can either rotate the thing itself or the light source. You'll see in just a bit when we look at a real quickie example why you really want to rotate the thing and not the light source. That whole shadow thing, that's not so cool if that is what's moving around your planet. And then a big deal is if you want to really look cool, then you also need to use some bump mapping technique. Does anybody know what bump mapping is? Without my slide. It's actually, it seems really complicated. It's kind of not. It can be done a couple of different ways because there's a number of different techniques for it. So one way is look at all the pixels in a bitmap one at a time, and you look for what's around it, and it looks for color differences to try to figure out where contours and things like that are, sharp differences in the color or saturation or whatever. And a bump map basically builds, think of it as an altitude map. So it uses the sharpness in those differences to build a separate file where each pixel represents not a color, it represents, I'm going to assign an altitude to that location based on the stuff I found it. And then that is used either in your ray tracer or in your OpenGL 3D application when you are calculating the lighting source on it. So if something is a higher altitude, then that's going to affect the way the lighting source affects pixels nearby and the way it does the shadows and changes the level of how bright or dark those colors are. But here's a perfect example because this is a regular sphere that we've mapped with orange. And this represents a bitmap of a bump map. So meaning in this particular case, it's too little, and you probably can't tell, but it's kind of just specked with dots. A lot of times what you're seeing is their grayscale images. So it's really like just a 0 to 255 number for each one of those pixels that represents map that and use that to represent the altitude level. And in this particular example, that applied to the totally orange sphere, and you get something that looks like an orange because it gets dimples that represent all those changes in the altitude. And it gets that little, the big black circle there is a whole bunch of changes in the altitude. Plainly, the higher number was lower in this case because you can see how it got represented. It looks like a little tiny crater. And for doing planets, it's exactly what you want. We'll skip right on by that, but that's just some examples really quickly of what we're talking about, of the bitmaps that either I am using or generating for applying to the planets. They're 2-to-1 aspect ratio, and how good they look, depending on the size you want to generate these frames, depends on like how high a resolution these textures are. So yeah, the only thing tricky on that is you start doing things like using OpenGL and Direct3D, and that size makes a difference because your GPU has a texture limit on, and they're all different depending on the RAM on the card and the GPU architecture as to, I can deal with textures that are up to a certain size. So a lot of these are all 4K. But one thing that's interesting is like certain iPhones, or a couple of generations back, like the really cool Three.js and WebGL samples won't work on it because they can't do 4K textures in the GPU on that iPhone. So you got to bump it down and do 2K textures. Okay, the planet.c project. So this is cool. And we're probably not going to get to look at the code, or we'll be here way too long. When we're all done, I will put all this up on my GitHub if anybody wants to play around with any of this stuff. This is a cool project, once again, written by a guy 20 years ago. He still plays with it, and he still keeps it in C, which is nice because he just gives you the source and a makefile, and you can build this for anything you could possibly want. It has 0 dependencies. Yeah, it's crazy. Like, it's a command line utility. It generates bitmap files for you in a couple of formats. Without the right command line utility, you tell me why you'd want to do this. It will fill your screen with garbage because it'll send it all to standard output if you don't tell it a file. Why you would suddenly want a bitmap file and garbage across the screen. But that is what it does. It's really cool, and it's what I was using and integrated into my application for doing the generated stuff. The CLI does have like a million options for how you can use it, which we won't worry about. The one nice thing about it is it supports color maps. So when I was playing around in the old version of the application where you can visually see what it's doing, I had a drop down for like the pre-built ones that he ships with it. They're just text files. But you can build your own color maps because you'll notice most of the planets we've done so far are sort of Earth-like. I mean, they're Earth kind of palette colors. They don't have to be. They can be purple and red and whatever you want to do. So it's pretty cool. Oh, we're not going to play with it, but I'm going to show you. And like 5 years ago, he's been working on this for 20 years. 5 years ago, he made this website. Which you fill out a bunch of stuff, and it runs his little command line utility in the background, and then it gives you whatever the bitmap of whatever it generated. Although it's funny because I don't know what he's got it run on, but he has got really serious hard set limits. Yeah, no generating 4K textures on his little website.
This website seems like it doesn't have any dependencies.
Oh, it definitely, yeah, plainly does not. And yet, it's super effective.
Dude, I don't need CSS.
So what did I end up with? So what I ended up with is a .NET Core application that I can run on Mac OS and I can run on Linux. I basically, because of how I had done that old 10-year ago Windows Forms application, I just pulled all the UI out of that and built that all through the command line as a million different parameters to set all those values. But all the rest of the code I had done was all in a bunch of separate classes that were just one for the ray tracer and a couple of utility classes. And two things. One, they worked in .NET Core. I changed one line of code. And that was only because I did something stupid. Those glow effects, I'm purposely taking a color and I do a tiny bit of a gradient that this is not high resolution enough for you to be able to tell any difference, but I have a high and a low version. And there was a function that I could use that would like take any color and would make a light saturated version of that. And I was using that, and that was in like the WinForms namespace, which I don't get to play with because that's their desktop application stuff. So one thing that I had to ditch and write my own function for that. And this thing built and did what I wanted, which is pretty awesome for 10-year-old written for whatever version of Windows that was code. I will say there's a little tiny bit of a cheat in the lower left. You will see that I make a note, and that is there is a lot of things that I was making use of in that 10-year-old code. .NET for a long time has had really sophisticated graphics primitives for working with bitmaps, for splitting images, for doing all resizing, all sorts of cool stuff. And the original versions of .NET Core, of course, did not support that because all that stuff in the .NET framework was written for a subsystem of Windows called GDI. What does that even stand for, Craig? Graphic Device Independent something. And GDI was actually has been baked into Windows for a very, very long time, but there is no equivalent of, I mean, there is, but it's not GDI on Mac OS or under Linux. So there was a lot of stuff that I was like, oh man, those things were awesome, and I made really heavy use of that. So fortunately, .NET Core's got essentially the same package manager that the normal .NET framework does. And Microsoft, very nicely, through the .NET Foundation, one of those projects they supported, is that they went and took, they created this package called Microsoft.Windows Compatibility. And there's a bunch of things in there. The one I cared about is all those cool GDI-dependent graphics primitives. They went and rewrote those to have essentially the same API calls, but not rely on that only in Windows GDI stuff. So I did add one package because I wanted to keep those API calls the way they were rather than have to rewrite that. But that's about it.
So you cheated.
I said it was a cheat. All my code was not using GDI, but some of it was. I cheat. You cheat wherever you possibly can. I wanted very purposely to create all those frames. So my really smooth stuff is I actually generate 120 frames for that rotating planet, and I might want to do a 1,000 by 1,000 pixel image for that. So it's a bunch of images. I write them out as PNGs because I always write it with a transparent background, so it doesn't matter what you plop that on. But I also wanted to really easily take all those and make an animated GIF out of that. Well, I wasn't going to write that, so that's all done in ImageMagick. So because why would you do that all over again? So yes, absolutely. Texture. No, and he wrote it all in C 20 years ago. But so there you go. There's some cool planets. that I just threw together ahead of this so you can kind of get a feel. Oh, those are a little smoother up there. These are kind of low res. In fact, I think these are like 140 by 140 pixels, so they're way low res. Yes, Jonathan.
Is this set to a white matte, or is it part of the lighting effect? Is the PNG set to a white matte?
No, that's the glow thing that he was talking about.
Yeah, you're talking about around it? Yeah, so here's the thing. That's why in my both the old version and the new version, that glow effect is optional. But what you can't tell is that in whose game are you going to have a planet on a crazy purple with diagram background? It's going to be on stars, right? Or space or something. And the cool thing is this shadow effect. I mean, the shadow effect is a big deal for how cool it looks. And what I found is when I originally wrote it 10 years ago and I went and found like just, looking at like what other people had done or images, not necessarily have done this, but here's a cool image. I found lots of cool things of tutorials for how to use Photoshop to do that, for one frame, which was a long involved thing. And of course you could make really cool looking stuff. And to me, the coolest ones always did that little glow effect. I just like the way it looks like on a starry background. The fact that that's there gives a little bit of a sense. Otherwise, it also is a little weird without any kind of that glow effect. Then the shadow just like fades into black if you put it on a star field or a black background, which also, is kind of a cool effect in itself, but I thought looked a little weird. Hence, I always generate them with that little glow. Although you'll see, I think with these, when I was generating them, I purposely was choosing this color that's somewhat complementary to the purple I knew I was going to drop it on. With this one, I forgot to go check that, and so I left it on figure it out yourself. So it looked at the planet colors and came up with an average, and it used that to determine how to do the glow effect. Okay, so what about the WebGL stuff? So, I'm gonna look at an example. I'm not gonna take you to this guy's blog. We're not gonna look at his code. Yes?
Right before you get there, what's the weight, what size is any given one of those planets?
These, you mean in pixel?
In megabits, kilobits.
Oh, they're tiny.
Really?
Yeah. They're 100 well, these, for one thing, these at this point are now animated GIFs.
Right.
So meaning it's a compressed format. Each frame of that, and these are I think that's 30 frames. So this is 30 frames of 140 by 140 pixel images. So it's pretty small.
Okay, cool.
Yeah.
Can we expect some Slack emoticons?
Maybe so. Can I make ones that rotate? I don't know. Okay, so what I'm going to do here instead of what I'm saying I'm going to do is, am I running this still somewhere? Okay. I'm just going to show you a real quick example. And we're not going to run through his code because we don't want to be here all night. And I'm doing this because otherwise Chrome will go all nuts with CORS errors if I try to do this on local. There you go. So there's doing the same thing in Three.js using WebGL. He's using the exact same, or two things that are cool about this. One, he's using the exact same techniques in all those layers that I am, exactly the same. He's doing one thing cool that I'm not doing that I will talk about here in a minute. But this is in it's like 25 lines of code. It's crazy nothing. So yeah, and the canvas can be anywhere, right? You can embed that wherever you want. So it's really a cool technology. Oh, by the way, we're just watching it rotate, but I can pick it up and drag it around, or I can zoom in and out. And now that's because he's purposely capturing those mouse events and changing the camera accordingly. He doesn't have to. You could, in fact, this frame might not be moving at all. It might be perfectly still, and maybe I hit a button and it rotates it slightly, and I hit a button and it rotates slightly, or whatever. But you can also set up objects in a 3D scene along a path and say, I want this one to turn around, I want this one. So your question weeks ago that you were giving me crap for why this wasn't going to include like a full solar system with like orbital mechanics, which plainly it does not. But you could totally, that would be like the next thing you would do is, all right, I'm going to take this scene. Yeah, no, that's what you should do with it, not me. Actually, one of the more interesting things here, because if you've ever done any 3D with a scene and the objects, so the star field that we see behind here, he's using a wonderfully hacky method for doing that. There is a larger sphere that you can't see, and that star field is mapped as a texture to the inside of it. And then he's put the camera inside that other sphere. So this is like a smaller sphere within a sphere. So meaning if he let us zoom out enough, you could pull the camera all the way out. It would like totally break that effect. But it is pretty cool.
This doesn't have ambient light, right?
It doesn't have what?
Does this have ambient light?
Well, I mean, there is a light source.
So there's a light source. So in actuality, like light hits the planet, bounces off the planet, bounces back off something else,
All right.
back onto the planet, you get
Well, now,
you get light coming from some.
right. So here's what I want to show you that's different, because his rotating and like me moving it, see, it's doing different things. So when we sit here, what he's got is the planet rotating. When I grab it and move it around, that's not what it's doing. I'm not rotating the planet. Let's find the light source. There we go. See the light source? I mean, here's the main. See, I'm moving it. So I'm actually moving the camera around the object. Yeah, so like, then I get back here to the back and I let it just sit here, and it's really boring because it's never going to get brighter. The light source is over on the other side, and we can't see it now.
There isn't code written for reflection, for instance.
Okay, yes. All right, Jonathan, let me find you an example. All right, so do you see that obvious light source? Yeah. Check this out. Where'd it go? That's called a specular map. So yes, he is doing that. So basically what it is a specular map is, now I'm going to give you another bitmap layer, and I'm going to define all the reflective surfaces in that bitmap. And you can change by, once again, they look just like grayscales because you can change the amount of reflectiveness. So in his example here, he's going one step further. He doesn't have lens flare and all some of those crazy things I did, but he did do one thing I would love to add, which is he's doing that specular map, which is he's figured out where all the water is, and he's like set that at a certain level of reflection so that the light source kind of bounces off the water, but it doesn't bounce off the land. Yeah, because it's not reflective.
Are the clouds part of the same bitmap as the
Different.
Oh.
Different. Yeah, in this case, you'll see that's another layer, and he purposely, if you look at his cloud layer, it's like super thin. Here, let's look at,
There isn't anything going on with the parallax effect in this, right, with clouds? Should they be some distance from the land?
there is not, but Three.js does support that.
Oh, that's cool.
Okay, and this is the same one, but all right, let's get back and refresh that. All right, that's the same one, but like took one of my textures, although I took a texture that has like hardly any land. This is like the all-water planet. But the same thing that came out of, my little application was for building an animated GIF or giving me individual frames for this, but I can take any one of those individual bitmaps that I was using that was generated, that I was applying and doing all those effects to, throw it in, in the same way, or throw in my own cloud layer, because that's my cloud layer, not his. And yeah, it's just crazy easy. Yeah, it's cool stuff. Okay, this is the last slide. So this is just meant as interesting next steps. Oh, and by the way, yeah, I brought the code along, but we're gonna skip going through that and running it. But like I said, I will post it up if anybody is curious to go through and play with any of this. So yeah, things that would be fun to do with it is skip the command line thing. That's actually fairly effective. Originally, when I was doing this, I got carried away. What I really wanted was a command line utility, because I needed to make a ton of these. So I wanted something I could script. I don't care how long it runs, overnight, make me 300 planets kind of thing. But I, got carried away with the fun and tweaking all that. It would be fun to do this as a modern web application. And do the same sort of thing, and do that probably using WebGL. That would be super easy to do that. The only complicating part would be, okay, well, what if you want that same ability to now package up and send me a zip with 120 frames of that same thing, or generate all that sort of stuff. That could totally be done too. Another thing, it would be nice, yeah, to go back, even in this .NET Core version, would probably be pretty easy to make multi-threaded now, even though it uses my old ray tracing technique. The time it takes to do one of those frames, pretty darn quick. The time it takes to do 120 of those frames in sequence is not so quick. So yeah, if it spun up a process and did that, that would be pretty cool. The reality is, it probably should do none of that. It should be a command line utility that doesn't do any ray tracing and doesn't do WebGL. It just uses OpenGL directly to do all this off screen, all that compositing, display a frame, grab the snapshot of that, programmatically move it a tiny little bit, grab the next frame, all the rest of those steps. Because you could actually do that. You could build this that would feel nearly instantaneous to run it, even if I wanted 120 frames. So that would be the real cool way to do it. I called out OpenTK because, of course, there's plenty of OpenGL .NET wrappers, just like what Three.js is to WebGL, including, that's one of the popular ones, and I call it out because it's available for .NET Core, so that would make sense if I was going to do it that way. You could do really insane stuff, like try to do it in WebGL using headless Chrome. That would be a fun, challenging exercise that it would be hard to justify why you would take that particular technique. Although, you could keep your code the same. Yeah, right. You could avoid learning some new OpenGL wrapper or writing to OpenGL directly. You're right. You could do that sort of thing. The fact is, you can actually do this now. Headless Chrome, for the longest time, even though it supported WebGL, would not let the local PC use the GPU. So it's pretty limited for if you fell back to software rendering. And some version ago they fixed that. So yeah, you can actually do GPU accelerated rendering in headless Chrome. Yeah, we just talked about the specular maps. It'd be really cool to go back and add that. I love that, because that is a really slick effect, seeing the shiny reflective nature that's only on water kind of bodies. So that would be all cool. It'd also be kind of fun to go back and take all the things that I did that he didn't do are all completely implementable, using Three.js, like the lens flare effect and stuff like that.
What about snow?
Snail?
Snow.
Snow? As a filter, or you want snow on the, okay.
There's no Antarctica.
But that's only with the ones that we've generated. You will see, I have a bunch of those color maps include polar regions.
Okay, cool.
Yeah, so now I get snow on some of them. Yeah, no problem. Nice. All right. I hope that was entertaining, if nothing else.
Thank you very much.